Yep. Thank you. Alright, so what the hell's going on with this internet shit? Why can't it come up? AR. M. R. MECH. Do you know what MAC2 password? Is this it?
Yes.
Because you just can't get it to work. Oh, but it's all lowercase. Well, that's why, because I have them all in all uppercase. There you go. That's why. Okay.
The sinking airplane, the ground handling bus, and ground service bus. There are no controls for the ground handling bus.
We
The
won't pay
bus is
attention.
automatically powered when external power.
You don't have to pay attention yet. I just want to see if Virgilio can see the video.
Buses provide power for servicing the airplane. The ground handling bus and ground service bus. There are no controls for the ground handling bus. The bus is automatically powered when external power is plugged in. The APU can also power the ground handling bus. If external power is not available and the APU is running, the bus is automatically powered. If the APU is running and external power is plugged in, external power has priority. The ground handling bus powers the cargo doors, cargo compartment lights, and maintenance access lights. The bus is not powered in flight. Now let's look at the ground service bus. The ground service bus is for cabin service personnel. The ground service bus powers loads needed both on the ground and in the air. It powers cabin lights and outlets. Battery chargers for the main and APU batteries. And the left forward fuel pump, which supplies fuel to the APU.
Good to go?
When external power is the only source of
I moved the
power
camera, so I want to know if it's good
and
now.
the main buses are not
I'll
powered,
let you know when.
a ground service switch at the attendance panel at door 1 left can be used to power the ground service bus. Whenever the right main AC bus is powered, the ground service bus is powered. If the right main AC bus is not powered and the APU is running, the ground service bus is powered by the APU generator through the same ground service switch. DC electrical power is used to operate important items such as the primary flight displays and the navigation display. 2.
Cool. You can see the video better now. It's in a better position, the camera. I'm just gonna use the bathroom.
All right, hold on.
I have some different information about CB and something after later. You have to check my file. If you need, take one.
I'm sorry, can you repeat that?
I have some different file in my here.
Mhm.
If you need, take some. If you want.
Oh,
I have any. Circuit also very easy to see.
You got everything?
It's a Korean airline. We made CV like a chapter.
Well, that's nice.
yeah, that's pretty nice.
Yeah, each chapter is
Can you put that here?
Yeah.
Very nice.
it's
It
more,
was good to have.
Yeah, it is.
it's more easy to find
Pictures are always good.
location and channel number.
Like I have a CB list. It might be the same one.
All right. I think we're gonna start now.
Yeah, that's the one. I have it.
You have the same one?
Oh yes, same.
Nice. All right. So Air France is gonna come back in Air France should be landing in about 20 minutes or so. So we'll head out there at 5, give or take. We'll go to the plane. So I'm just gonna run through a bunch of CBTs that are gonna review the electrical portion. Virgilio, we'll discuss later what we're gonna do, but this should help at least prime you for our review. Then we're gonna go over some primary display CBTs, some AIM CBTs. We're gonna do front load a bunch of CBTs. I'm gonna go out to the plane. I'll FaceTime you, Virgilio. When that's all done, we'll come back. We'll knock out CMCS and we'll knock out ACMF and we'll call it a day. Tomorrow, navigation and autopilot. Friday, communications and lighting. We'll do our review, and then I'll let you guys decide whether you want the test on Friday or Monday. So, we'll see. Whatever you guys want to do. Doesn't matter. We can do it the first thing on Monday, or we can do the last thing on Friday. It's up to you guys.
How long is the test?
25 questions, give or take?
How many questions?
25? Alright, because it's about 10 chapters technically, so at least 2 questions per chapter, if not 3. So between 25 and 30.
Okay.
Something like that. So you guys decide whether you want to take it on Friday or Monday. It's up to you. We'll have a review no matter what.
Yeah.
I'm actually creating the review. Like I told you, we're going to use our phones and it's going to be the same question. So it won't just be a review of me asking, me writing down the notes, even though we could do that also. So what we can do, if you want, is that I will create a Word document and we'll just say everything we know, all the important things. And then I'll give you the Word document.
Mhm.
You guys can study off that over the weekend if that's what you want.
Okay.
It's your class. You decide what you guys want.
You're the teacher?
So I'm going to play this one and then we'll keep going.
Buses provide power for servicing the airplane. The ground handling bus and ground service bus. There are no controls for the ground handling bus. The bus is automatically powered when external power is plugged in. The APU can also power the ground handling bus. If external power is not available and the APU is running, the bus is automatically powered. If the APU is running and external power is plugged in, external power has priority. The ground handling bus powers the cargo doors, cargo compartment lights, and maintenance access lights. The bus is not powered in flight. Now let's look at the ground service bus. The ground service bus is for cabin service personnel. The ground service bus powers loads needed both on the ground and in the air. It powers cabin lights and outlets. Battery chargers for the main and APU batteries. And the left forward fuel pump, which supplies fuel to the APU. When external power is the only source of power, and the main buses are not powered, a ground service switch at the attendance panel at door 1 left can be used to power the ground service bus. Whenever the right main AC bus is powered, the ground service bus is powered. If the right main AC bus is not powered and the APU is running, the ground service bus is powered by the APU generator through the same ground service switch. DC electrical power is used to operate important items such as the primary flight displays and the navigation displays. Global Positioning System, or GPS, and the Air Data Inertial Reference Unit, or ADIRU. Now let's look at the sources of DC power. The 777 has 2 batteries. The APU battery powers the APU starter motor and APU control circuits. The main battery powers critical airplane systems when no other power sources are available. Battery functions are monitored by the Electrical Load Management System, or ELMS, and displayed at the bottom of the electrical synoptic. Also, battery messages are displayed on ICAS. The primary source of DC power is 4 transformer rectifier units, or TRUs. The TRUs convert AC power into DC power. They are powered from the 2 transfer buses. The TRUs, in turn, supply 4 DC buses. The left main DC bus, the right main DC bus, the captain's flight instrument bus, and the first officer's flight instrument bus. If a TRU fails, DC tie relays connect the left and right main DC buses, and the captain's and first officer's flight instrument buses. This allows all buses to remain powered. There are no controls for the DC system, as it is fully automatic. The Flight controls on this airplane are actuated hydraulically, but controlled electrically. This is known as fly-by-wire. There are 2 backup generators, one on each engine. Each backup generator is a non-time limited backup source. We'll discuss the backup generators in more detail in non-normal operations. 2 permanent magnet generators, or PMGs, are housed within each backup generator. These PMGs are the power source for the flight controls. The PMGs provide dedicated power to left, center, and right power supply assemblies and their respective flight control DC buses. If one or more PMGs fail in flight, the main DC buses or the captain's flight instrument bus power the flight control DC buses. If the main DC buses become unpowered, the hot battery bus provides power to the left and center power supply assemblies. Should a transfer of power from one source to another occur, 1-minute batteries are provided on each power supply assembly to ensure no interruption of power during the transfer. To allow automatic landings with the lowest possible minimums, the electrical system configures so that each of the 3 autopilots is powered by a separate power source. During approach, power to the right transfer bus switches from the right main AC bus to the backup generators. This transfer provides independent sources to each of the 3 autopilots. The electrical system returns to normal when an autopilot go-around is performed, or when the autopilots are disengaged.
Okay.
Good grammar and spelling are important, but if you want to write essays that inspire,
It's going to talk about the RAS.
777 has a backup power system consisting of 2 backup generators. These ensure electrical power is available for essential loads. Essential loads are powered by the left and right transfer buses. Essential loads include instrument and panel lighting, captain's and first officer's navigation and communication radios, and center pitot and engine probe heat. The transfer buses are normally powered by the left and right main AC buses. The transfer buses connect to one of the backup generators when their AC buses are unpowered. They are normally left on. The backup generator switch off lights remain illuminated until their associated engine is running. With the engines running and the backup generator switch is on, automatic switching is armed. Notice that the backup generators are running. Push the left backup generator switch to the off position. With the switch off, power to the transfer buses is not available from that generator, even though the generator is operating normally. Now reset the switch. The backup power system provides uninterrupted transfer of power to essential loads in the event of loss of one main AC bus, the loss of both main AC buses, when only one main generator is available, and during autoland. In the event of loss of all main and backup generators, a standby system powers critical AC and DC equipment. Critical AC loads include center ILS and radio altimeter, marker beacon left, ATC transponder left, POR left, and engine igniters. Critical DC loads include the captain's and first officer's flight instruments and displays. standby system consists of the battery buses, the captain's and first officer's flight instrument buses, and an AC standby bus. Normal power for these buses is from the left and right AC transfer buses, either directly or through TRUs. Should the transfer buses become unpowered, the ram air turbine, or RAT, provides DC power through the TRUs. And the standby AC bus is powered from the battery bus through a standby inverter. The ram air turbine, or RAT, can be deployed in flight to provide electrical and hydraulic power simultaneously. It is the primary source of standby electrical power if all normal sources are lost. It is located in the aft right fairing and is a non-time limited source of power. However, its output is small, providing less than 1/10 the power of the other generators. The RAT is deployed automatically if both AC transfer buses are unpowered, if all three hydraulic system pressures are low, or with dual engine failure and the center hydraulic system pressure low. If the RAT fails to deploy automatically, the crew can deploy it manually. The ram air turbine switch is located on the hydraulic panel. Deploy the RAT. The ram air turbine unlocked light illuminates when the RAT is not in the fully up and locked position. The pressure light illuminates when the RAT is producing normal hydraulic pressure to the flight controls. If the RAT is unable to maintain hydraulic pressure, the electrical load is shed until hydraulic pressure is satisfactory. When RAT electrical loads are shed, or during periods prior to RAT deployment, the main battery powers the standby power system. When the RAT provides electrical power, both the captain's and first officer's flight instrument buses are powered. When the battery provides standby power, only the captain's flight instrument bus is powered. Now let's look at some non-normal indications. Shortly after takeoff, the ICAS advisory message, electric generator off left, displays, and the off light in the generator control switch on the overhead panel illuminates. A generator fault caused the protection circuits to trip the field and the generator breaker to open. Pushing the left generator control switch off and on resets the system. Reset the left generator. The fault was temporary. The ICAS message is removed, and the generator operates normally after resetting. During climb, the ICAS advisory message, electric generator drive left, displays, and the left generator drive light illuminates. The message indicates there is low oil pressure in the generator drive. Hold the guarded switch for 1 second to disconnect the generator drive from the engine. The generator drive is now disconnected. It can only be reconnected by maintenance action. High generator drive temperature automatically disconnects the generator drive, giving these same indications. With the generator drive disconnected, the message electric generator off left also displays, and a backup generator is immediately connected to the left transfer bus. associated engine generator is lost for the duration of the flight. The right engine generator powers the left main AC bus. Power to the left transfer bus is supplied by the left backup generator. The APU can be started to provide a second generator for the system. Start the APU. The ICAS messages may be canceled. Cancel the messages. After the left engine generator fails, the right engine generator fails. The APU now powers both main buses. With 2 generators lost, the right backup generator powers the transfer buses. Only one backup generator at a time can power the transfer buses. Reset the master caution system. 3 crews. The caution message, electric AC bus right displays. This indicates the right main AC bus is unpowered. Items powered by the right main bus are lost. However, the backup system continues to power the transfer buses. The ICAS messages may be canceled. We are cleared to descend. The ICAS advisory message, electric backup generator left displays, and the backup generator off light illuminates. This indicates the left backup generator has failed. Notice the right backup generator continues to power both transfer buses. Pushing the backup generator switch off and on allows the circuitry to reset. Reset the backup generator. The condition was temporary, and the left backup generator is now back online. You are cleared for the approach. Autoland is possible with one main generator and one backup generator operating. Several electrical ICAS messages are for crew awareness only. There are no associated orals, and crew action is not required. Information about these messages is available next.
All right, so that's the electricity. I know, Virgilio, you haven't, you probably were lost, but it's okay, I'll catch up with you. Meanwhile, James, and Dennis, do you have any questions regarding electricity? No? All right, so let me just, I'm gonna turn on the light real quick. And so let's just write some fun facts about electricity here on the board. Virgilio, I'll send you a picture of this. Some fun facts.
Fun facts.
Okay, so let us talk about how many. Okay, so how many IDGs?
2.
Good. What is the frequency? Or let's do what's the voltage?
115.
Frequency?
400.
And what is its rated power?
120.
Very good. 120 kVA. Beautiful. Good. We got APU gen, right? Only one.
Mm-hmm.
Same.
Mm-hmm.
Same. Same. Good. We have, let's do the bugs. How many bugs?
2 bugs,
Beautiful. 2 bugs. Voltage?
115,
Beautiful. Frequency?
400,
What is it?
400.
It's variable.
Oh, variable.
Variable frequency. And it's about 390-ish. So like 510. Okay. And what is its rating? Only 20. Only 20. Okay, not 120, only 20. The frequency here, change the color. Frequency here is moved from variable to constant by the backup converter. Good. Bug converter. How many bug converters are there? One. They share it. Excellent. Okay, external and primary power. So I'm just going to put external power.
Mhm.
Should be, I hope.
Mhm. Well, not in terminal 1.
Right, I hope so. Frequency, the same thing. And then 90. Minimum 90. Always put 90. If you can, Boeing suggests that you put more than 90 kVA, just so that you don't have you don't have load shedding, and then you don't have the contactors open. All right, cool. Those are our sources. Let's go here now. ELMS,
Electric load management system.
electric load
Management.
I'm gonna put it here. Management system. Beautiful. How many power panels? I'm gonna put here power panels. How many?
134.
4? Name them to me. I'm gonna leave them blank. Name them. P what?
P100, P200, P300,
P300.
P110.
So that's where we change. So we go here, and we're gonna put P110 here. What are the other ones?
210 to 310.
320.
Beautiful. P320. These, there's only 3 power panels. These are called power management. Power management panels. What is the difference? There's 4 of them. What's the difference? Here, the load should be
25 amps.
greater than 25 amps. Beautiful. And this is less than 25 amps. Okay? So, anything, if you're looking for a big circuit breaker, 100, 200, 300. If you're looking for little breakers, 110, 210, 310, 320. Okay, let me see if I can actually move this for Virgilio. There. All right, cool. So, 3 of those, right? So greater and less than. Good, good. What is the point of these power magnet panels? What else do they have inside of them aside from circuit breakers? So they have what do they have? You have circuit breakers,
Contactors,
contactors,
relays.
right? And that's it, right? And then you have the things that control them,
Mhm.
depending on it, whether it's the SIUs or CCPs, all that good stuff. I'm not worried about you knowing whether that exists or not. What I just want you to know is that the ELMS panel, not only do they have all the circuit breakers, but if you open up the doors, they have circuit breakers, contactors, and relays in there.
Okay.
Right? So that's what I want to know. What else? What is this acronym stand for? BPCU.
Bus power control unit.
Thank you. Bus Power Control Unit.
Only one.
There's only one. Nice. And what does it do? What's its job?
Oversees the operation
Yeah.
of the GCUs.
It does. But okay, so let's refine that. I use that as an analogy to say yes. It basically has the final say.
He's a wife.
It's the wife, right? You are your own boss, but your wife then can tell you no. So bus bar control, it controls, like it says there, the contactors. Let's refine that. Some contactors. I'm gonna put contactors here, right? And it's also in charge of the no break power transfer. And that's what I mean by that. That's the wife. Why is that? Because every generator has a GCU, right? Which is a generator control unit. And they close the contactors, right? So everyone depends. So I'm going to put it here in parentheses which one have it. Left engine, right engine, APU, and that's it, right? Because the bugs have the converter, right? Now these close contacts too. They close their own contactors, and they also close the bus tiebreakers, right? Even though the ground control unit, or the generator control unit will close like the system itself, so if it wants to power the right system for the right engine, or the left system, it's going to control that contactor. And it also controls the bus tiebreakers up in they have switches for in the overhead panel. But this bus tiebreaker, the final say is by the BPCU, because if there's an interruption of power, this makes sure that they don't open. So if we really want to be specific, the GCU opens and closes, but the BPCU gives it permission, the final say. Does that make sense?
Yeah.
So if the question in the test said, what controls the contactors? What device controls the contactor on the right main AC bus? It wouldn't be BPCU. The answer would be the right GC, the right IDG. The right
GCU.
Right GCU, right? It would be right GCU because it actually is the one that physically sends the signal.
Mhm.
But this one first tells it it's okay.
Okay.
But this one is the one that sends the signal to the bus tie. All right, cool. That looks good in terms of electricity. I'm sure I'm forgetting some things. Let's take a quick picture. Okay. What else can we say? What else could we say? It's important. I mean, honestly, those are the main takeaways. Okay, so we're happy with that? So I'm going to put TBT now. About, what can we put now? We can put... Okay, we're gonna do flight displays.
You might want to move the camera.
Yeah, I'm gonna move it. Thank you. Screen. Let's see what goes on here.
The primary display system has two major functions. It provides information to the flight crew about the state of the airplane and its systems, and it allows the flight crew to manage this information and interface with the rest of the avionics systems. Airplane information is displayed on 6 flat panel display units. There are 4 graphics generators which generate all the graphic symbols that appear on the display units. Each graphics generator can be thought of as a display channel. Normal system operation is with 3 channels, each driving 2 display units. The remaining channel acts as a backup. Any one channel can provide information to the display units, although in a degraded mode. The display units themselves are designated left and right outboard, left and right inboard, and upper and lower center. The The lower center display unit, as well as the inboard display units, are called multifunction displays, or MFDs. MFDs can be used to show a variety of information in different display formats. At airplane power-up, the primary flight displays, or PFDs, are on the outboard display units. Some of the PFD indications are attitude, airspeed, and altitude. The navigation displays, or NDs, are on the inboard display units. ND can show both full compass rose and expanded rose HSI indications, as well as a moving map display. The engine indication and crew alerting system, or ICAS display, is on the upper center display unit. The lower center display unit initializes to the secondary engine display and is the recommended display unit to use when displaying other MFD information. Before we discuss the displays, let's first look at some of the display unit controls. Inboard display unit selectors are located here on the left and right forward panels. These selectors allow the pilots to manually control the inboard display units. Each selector has identical positions. Let's use both selectors to help review their operation. Rotate the left selector to the PFD position. The PFD position selects the primary flight display to the inboard display unit. Notice the PFD is no longer displayed on the outboard display unit. Now rotate the right selector to the ICAS position. Touch the highlighted area. Observe that the upper center display unit is blank, and ICAS is now displayed on the right inboard display unit. When either of these displays is switched from its normal display unit, the normal display unit blanks. Now rotate both selectors to nav and watch the displays. The nav position selects the navigation display to the inboard display unit. Notice the captain's PFD and the ICAS display return to their normal locations. When the switched displays are deselected from the inboard display units, the outboard and upper center display units reinitialize. The PFD, ICAS, and nav positions allow you to lock that respective display onto the inboard display unit. The selector must be rotated to another position to manually change the display. Now rotate both selectors to the MFD position. Nav is one of two normal selector positions. MFD is the other normal position and also the pre-flight setting. Maximum display flexibility is achieved by operating the inboard display units as multifunction displays. When MFD is selected from PFD or ICAS, the ND automatically reinitializes on the inboard display unit. In MFD, other displays can be selected to the inboard display units by using the Display Select panel. The Display Select panel is located here on the glare shield. The Display Select panel allows the flight crew to select different displays on the lower center, as well as the left and right inboard display units. Let's look at the Display Select panel controls. These display switches are used to activate a display unit for subsequent display selections. Only one display unit can be selected at a time. The annunciator light above the switch indicates that the left inboard display unit is now active. If a display unit is inhibited from accepting inputs, the light will not illuminate. To illustrate this, rotate the right inboard display selector to nav. Touch the highlighted area. The annunciator light did not illuminate because the right inboard display unit is currently locked to the navigation display. As a result, other displays cannot be selected. The left inboard display unit remains active instead. Selection of an inboard display unit on the display select panel is inhibited whenever the associated selector is in PFD or nav. In ICAST, limited display select panel operations are possible. Those operations and other display unit inhibit conditions will be discussed later in the lesson. Before we go on, return the selector to MFD and push the lower center display switch. The MFD select switches are used to select MFD displays to the active display unit. System synoptics represent the majority of the MFD displays. Specific features of each display are described in the respective system lessons. A synoptic is an abbreviated schematic that displays status information about the system. Synoptics are not required for any crew procedures and should be used only as references. To discuss some common synoptic features, push the fuel synoptic switch. Green lines represent the movement or flow of fluid, electricity, or air. White lines connect system components when flow is not present. Most system suppliers, such as pumps and generators, are represented by rectangles. These pumps are on and supplying pressure. This pump is on, but not supplying pressure to the system. Amber symbols indicate a failed condition. Valve symbols indicate both valve position and status. Selecting a new display automatically replaces the previous selection. Push the electrical synoptic switch. Now push the electrical synoptic switch a second time to remove the electrical synoptic. Notice the lower center display unit. When the lower center display unit is active, removing an MFD display blanks the display unit. However, on an inboard display unit, the ND displays again, since it is the initialization display on those display units. The navigation display switch is similar to other MFD switches and provides another way to display the ND on the inboard or lower center display units. The ND, however, is not considered an MFD display. It cannot be removed from the inboard display units, just temporarily replaced. The remaining display select panel control is the ICAST message cancel recall switch. Its use is covered in a later lesson. Before we continue, here's a chance for you to practice with the display select panel. For this exercise only, the communications display is inhibited because it can appear on only one display unit at any one time. You can select any other combination of switches you desire. Touch the green arrow when ready to continue. Flight Instrument System, or EFIS, control panels are located here on the glare.
We fight the battles no one hears about. They're the
Oh,
ones who go before us.
Glare shield. The EFIS control panels control the PFD and ND displays. Detailed discussions of their operation come later in the PFD and ND lessons. For now, let's look at how the display system determines which panel has control over the three possible ND locations. Normally, when an ND is displayed on each inboard display unit, the associated panel controls that display. If only one inboard display unit and the lower center display unit contain NDs, the pilot without an ND on his inboard display unit controls the lower center display unit. If neither inboard display unit contains an ND, but the lower center does, then the left EFIS control panel controls the display. If both inboard display units and the lower center display unit all contain NDs, then the left EFIS control panel also controls the lower center display unit. The left inboard and lower center displays will be identical. MFD formats which require crew interaction, such as the communications display, are controlled with the cursor control devices, or CCDs. pilot has a cursor control device located here on the control stand. The cursor control is used to control a cursor on an MFD display that requires a cursor. The MFD that displays the cursor is determined automatically when display select panel selections are made, or manually when the cursor location switches are used to activate a cursor on the selected MFD. The cursor location lights on each cursor control device indicate which MFD is displaying this cursor.
Yeah, let me see if it comes up.
Each CCD controls a unique cursor symbol. The cursor shown here is controlled by the left
Yeah.
CCD.
But I can
Push
figure it
the
out with
lower center cursor location switch on the right CCD to display the right cursor symbol. The cursor is moved by sliding a finger across the touchpad. The touchpad is a capacitive glass surface which translates finger motion into cursor movement on the display. Moving the cursor over an active display item selects it. As the cursor moves into an active area, the item is highlighted by a white border. Pushing the cursor select switch activates the selection. Push the right cursor select switch. Touching a corner area immediately moves the cursor to that part of the display. The areas must be touched. Simply sliding a finger to a corner does not have the same effect. Try touching the corners of the right touchpad. Touch the green arrow to continue. Touch the highlighted areas. Touch the highlighted areas. Touch the highlighted areas. The cursor control devices are used for making selections on the checklist and communication displays. Let's look at which cursor appears when these two displays are selected. Display the checklist on the left inboard display unit. Touch the highlighted area. When checklist or communications is selected onto the left or right display unit, the associated cursor for that side appears. Now select the communications display to the right inboard display unit. Touch the highlighted area. If different displays are on the display units, both cursors can be used independently. Now select checklist to the right inboard display unit. Notice the cursor on the left inboard display unit is removed. When the same display is selected in two places, only one cursor can be active. In this case, the last pilot to make the selection will have control. Now select the communications display to the lower center display unit. When selecting a display to the lower center display unit, either cursor could appear. If you wish to control the lower center display unit and the displayed cursor is not yours, pushing the lower center switch on your CCD displays your cursor. Display the first officer's cursor on the lower center display unit. Notice the first officer's cursor is removed from the right inboard display unit. Each cursor can only appear on one display unit at a time, and both cursors cannot appear on a single display unit at the same time. The last pilot selecting his cursor to a display unit will have control. Next, let's look at the display brightness controls. Manual brightness controls for the pilot's display units are located here on the sidewall panels. Each pilot has individual controls to adjust the brightness of the outboard and inboard display units. FD displaying the navigation display. The last controls we'll look at are the display control switches. Display control switches for each pilot's inboard and outboard display units are located on the instrument source select panels. A single switch for the center display units is located on the center display control panel. All of the switches shown here are in the normal pre-flight position. Operation of the navigation source and air data attitude switches are covered later in the ND and PFD lessons. All three display control switches operate the same. Push the left display control switch. When the switch is pushed to the alternate position, an alternate display channel is selected for the associated display unit pair. The switches are available for cases where a display failure may go undetected and automatic system reconfiguration does not occur. But what happens if a failure is detected? Let's look at some non-normal conditions. Automatic reconfiguration after a display unit failure is similar to what can be done manually using the inboard display selectors. If an outboard display unit fails, the PFD automatically switches to the inboard display unit, regardless of the inboard display selector setting. If the upper center display unit fails, the ICAS display is switched to the lower center display unit and replaces whatever display is present. When one center display unit fails and the other displays ICAS, the remaining display unit then operates in a limited mode. Similarly, whenever an inboard display unit displays ICAS, it too operates in limited mode. For an example of limited mode operations, select the secondary engine display to the lower center display unit. The display unit now shows the compact engine display. This display is created when a display unit is in limited mode, and the secondary engine display is selected to the same display unit. Repeated pushes of the secondary engine display switch will toggle the display on and off. When the display unit mode is limited, only the fuel and air synoptic switches remain operable. Display the fuel synoptic. In limited mode, the expanded fuel quantity indications display instead of the fuel synoptic. Now display the air synoptic. Likewise, the pressurization indications display instead of the air synoptic. Features of both indications are discussed in their respective lessons. The single source display's caution message appears when only one graphics generator remains functioning. Left inboard and outboard displays are echoed on the right display units. All right display unit controls are inoperative. The inboard display units can no longer be used as MFDs. The lower center display unit is the only MFD available. Cancel the message. Finally, in the event of an EFIS control panel or display select panel failure, backup control is available through the control display units. These backup operations are covered along with other CDU operations in a later lesson. This completes the instruction section of the lesson.
All right, guys, I think we're gonna go outside now.
All right,
Restore.
cool.
All right, I'll FaceTime Virgilio. I'll FaceTime you. Let's get ready.
Where's the plane at?
Gate 4.
Gate 4?
Yeah.
Of course.
Thank you. Yeah, no, right, of course.
So you want to do meanwhile? Gonna go to people.
Delicious. Oh, speaking today. Good. No problem at all.
getting crazier by the minute. How about you? No coffee?
No coffee.
You don't wanna be up all night long? You don't wanna be up all night long, huh? I'll eat a banana later, okay?
Yeah, no problem. Enjoy.
Still active? Yes. You took a picture, right, James?
Yes, yes.
Yeah, it's cleaning. Some of it doesn't, but that's because the board is already old. It's like the coating has peeled away.
Right.
So, but it's better than before for sure. We forgot to put, he has a rat, his KVA is 7.5. It's the only thing I forgot to put.
Okay.
It's really low.
20 and 7.5.
Yeah, those are the weird ones.
Sure you don't want that, Joe? Because I couldn't sleep the other day.
No. There's times I drink coffee right before bed and I go to sleep fine.
Yeah, me too.
Coffee doesn't, but I drink it for the taste.
Me too. I don't drink it to be
No, me neither.
Still strong.
Yes. Yeah, I go to sleep no matter what.
That glue off works, huh?
Takes out anything.
Shit. What is this supposed to be? Wow. I heard about it, but I never used it.
Done here. What do we need? What still need? I need. It's okay, guys. I'm gonna get a coffee real quick.
No problem, brother. You know, I took my mask off and I don't know what the hell did I do with it. The other mask.
There is I have you one.
No, I have.
But you
Yeah. Look, I mean, I'm just saying my cloth mask. Besides that, I got these. You know why? Because sometimes you go in cockpit and the pilots, then nothing. You know, and it's a very enclosed space, so I'll put an N95. I don't know. I don't know if it's because they're getting tested every time they get on a flight. I don't know. Is this yours?
No, it was somebody I think used it. I saw one pencil, one pen is over there.
Yeah, that's why I said clean it.
I don't know who used this. What night?
I don't know. No idea.
Yeah, see, Dennis? It goes into the gray water from the lab and the galleys. They stay in the drain mass.
Well,
They stay in the drain mass, and what happens is that the same concept, not that when it reaches a certain level, but, well, it does reach a certain level, but with the weight of the water, it sits on this valve, and when there's too much pressure on it, like too much weight, then it releases. So it's closed, water releases, but it doesn't go into a tank.
I
Just stays in the mass.
wonder why they did that.
I mean, it was the first time a gray water valve was on a plane, right?
Yeah, I mean, for the 787, though, that was the first time I'd seen it.
Right. But the 777 was the first plane that had it, like the system, gray water
Okay.
system. Right. No other Airbus. The Airbus doesn't have it.
Uh-huh.
Airbus doesn't have it. 57, 67, 47, none of that. So 777 was the first one with gray water valve. So I guess they put it in the drain mass. that thing I'm telling you, the issue with BA would get it a lot. I guess maybe because of the older planes, they would get it a lot where that valve wouldn't open.
Okay.
Right? It has a fail safe, and so you're right. And so then it would come back up. And so part of the MEL is just leaving it open, like making sure that it stays open so that it always drains. That valve I showed you, that gray water valve there, that's how you lock it out. Always leave it open. That way you never accumulate. And then I figured when the 7A came out, I said, no, fuck this. We're going to put it in separate tanks as opposed to drain mass. But you see, it is. I just read it right now. It stays in the
Gray
drain.
water mean the pencil.
Dirty water, yeah. So when you
Yeah,
wash your hands, all that
okay.
water, and then the galley, so that's the gray water.
We leave it open, right?
Yes,
Yeah, on MEL.
if it's failed, MEL, to leave it, if like they say it's been clogging or whatever, you just leave it open. You lock it open. So there you go. That makes sense. Then they had it, and then the 7A said no, it didn't work too well because the 350 is the same way. There's a little mini plastic tank underneath each sink, and then like you said, when the pressure builds up, then it releases.
I mean, why would they leave it like that? I don't know.
Right?
I mean, they're the 777 is a transition plane, you know, which is it's a good plane. To get
No,
me wrong.
it's a great plane, but like you said, then so the thing is that when they went to the 7.8, they fixed all the wrongs of the 777, but they made it too complicated.
Oh,
Almost.
yeah,
Does that make
they
sense?
fucked everything
They
up.
made it too complicated, so they got too ahead of themselves. So if you look here, so here's the galley, blah 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 blah. So when the water drains, it doesn't go to the waste tanks. It goes down here to a drain mass, and it just sits there until it's ready to let go. And there's a valve here.
Mhm.
There's a valve here that once it comes down, this valve, then when it feels the pressure, it opens and dumps it. And
Only
this
one
is the
valve, or you got
No,
one
the
valve?
one for the forward and one for the aft drain mass. And this is the one for the gray system valve. That's the one I was showing you. Okay? There you go.
Okay.
Good.
That's all it is. So it stays in the drain mass.
Say, okay. Good to know.
I uploaded the videos here. All the videos I'm ever going to show you.
Mhm.
So if you guys want them.
Which videos? CVTs?
Like all, not the CVTs. Like all the videos you see the Delta guys coming.
Mhm.
Like I haven't shown you one in a while, but like when the Delta guy talks, it's like, yeah, this is. I have those videos if you want.
Okay.
Yeah. This is more for. This was I did for. What should I call it? I did it for, so they can send it to Virgilio. But if you want, as well.
You want the videos?
You want the videos, James?
Okay.
I mean, this is what we were doing right now, right?
No. So those are CVTs. Those are on YouTube. You can access those at home whenever you want.
No, but the Delta ones, what are they going to
Those are all the ones we're doing right now, yeah. They're all going to be in the PowerPoints, is what I'm saying. So you're going to see them. I'm just saying maybe you want them for whatever reason.
Oh, yeah. I mean, how big are they? They're not that big, right?
It's about almost 2 gigs.
Yeah. Oh, wow. Thank you.
Yep.
There's a cool USB, man.
Yeah, I don't even know how I just found it in my book bag. I'm like, I need a USB, and I found it.
Yeah, like, and it'll protect it.
Yeah, because it's metal, right?
Yeah. I'm surprised it doesn't interfere with the.
The only thing is it's just really it's really small. It's only 16 gigs.
Oh. If you ever give a 787 class, I got some good info.
You got other stuff?
Yeah, I got on 787.
Okay, good. I'll bring a lot. Like, do you need a big USB for it?
No. I mean, like this one. Look, actually, this one helps me out a lot. This is a GPM matrix.
That's exact. So when I went on my 787 course, they had that, and that thing is okay.
It tells you all the
Yeah.
programs and stuff like that.
I thought when I was in my 7.8 class, which I thought was amazing. I wish they made it for all the planes. They had everybody got their own laptop, right?
Mm-hmm.
And in there they had the software where it was a 3D rendition of the plane. So if you wanted to see how long a wire is, any wire on the plane, it would show you. Here's the box, and it'll send you all the way to the wire to the RPDC. If you wanted to see a hydraulic line, it would show you everything, and so you can zoom in, zoom out. It was crazy. It was the craziest thing I've ever seen.
Because I seen one here. We have one that is the
I think it's probably that one. It was
That's
probably
the
that one.
component, but that you could actually click and then you could rotate
Rotate it. So that's the one. So Ray got it somehow. But Ray probably has he has the program. I don't have the program for it. I have the files like that,
Mhm.
but I don't have the program. But I think that's a great like learning tool so that
I
like
think
I'm
it's
talking
on the
about.
computer.
That's what I'm saying. So if it is, that'll be great for the 7.8 if I run the
Like you
7.8.
can pull it out.
I'm sure Ray knows how to, so that we can put it here, so that we can mess around with it. But that was like the best thing I've ever seen. But they don't make it for every plane. Well,
It would be nice for every plane, right?
that's what I'm saying. It would be nice if every plane had it.
Videos.
What video?
You put all the videos in it. No, you got a chance. I'm sure.
Yeah. All right.
CMCS.
CMCS. CMCS.
System. Not a function.
It's technically a function.
Oh, yeah?
So okay. So all right.
All right.
The system's no. Okay. So remember, everything on this plane talks to AIMS, Airplane Information Management System, right?
Okay.
The CMCF is the function in AIMS that allows you to access the ground test and all that.
Okay.
The system, the difference is that software in AIMS plus the map. That's all it is.
So the CMCS is in AIMS.
Correct.
The software is in
The
AIMS.
software is in AIMS,
Okay.
yes. And that software is in the CPM, standard, basic, or ACMF, whichever one, depending on the plane. So let's write that down right now. Let's write it right now.
Did you get the video?
Jump over to AIMS again.
Did you get the video file? Yes.
Yeah, I got the
You're
video.
able to trans.
This is yours, right?
Yeah.
You want to do one by one? I'll just make a new folder. Videos. And this one by one. Okay. All right. So here we go. Get this guy up.
Luckily, the other thing is magnetic.
It is, but I don't think this pipe is. All right. So let's not use blue because my son ruined it. Ames. Airplane. Information management. System. And the way they design it, the way in the chapter that they do, they put a nice little circle, and then they have the gateway. Do you remember what that gateway is called?
Nope.
How do I? Gateway. Gateway.
I'm not pretty sure we can find it, but
See, you have your acronym list there?
Yeah.
Let's go to G. This is important.
Oh, really?
Of course, it's not here. Gateway conversion interface card, something like that. We'll just find it. Gateway, there you go. Data
conversion.
There you go. That makes more sense. We need to break it down because it is important. So, data conversion management system.
No.
Gateway function, sorry. Gateway function. Right? And the purpose of this DCGF, the purpose of that DCGF is basically an interface, or again, another converter that changes whatever the information that it's coming from to ARINC 629. So, remember, the AIM system, right? And the AIM system, I'm going to draw it here. Let's draw like this. Or here. Or here. And then on the outside, I'm going to do these red ones to signify AIMS2. So anything in red is AIMS2. So we have how many IOMs? 4. Good. IOM, IOM, IOM. And this is exactly how they look like on the chassis. IOM. How many GGs? 4. Right. So CPM. So this is, you got to be careful. So it is 4
In total.
in total. We're looking at it per AIMS cabinet.
Okay, so it'll be
So it
2.
looks at CPM. GG. Good. Then we got 2 more CPMs here. One of them is COM for the communication. And CPM, this is AIMS1 I'm going to write here. So it is either basic or ACMF. The ACMF only lives in left AIMS. Okay? Good. So what the hell is this AIMS, or what is this cabinet? What is the function of this cabinet? Well, any information, put it in green, any information from any of the buses. How many buses we have, by the way? 11. Good. I'm going to write that here in this corner. AirInc 629 buses. We have 11 total. 3 of them, 4 of them, and 4 of them. 3 of them, flight controls. And they're labeled left, center, right. 4, system. Left, C1, C2, and right. And 4 are for the AIMS cabinets. AIMS cabinet. So these 4 are strictly for the left and right AIMS to talk to each other. Right? But anything that comes from this communication has to go through the IOMs. That's how they talk. That's how the AIMS talks. Except for the GGs.
Weather radar.
Yep, I'm going to put it here. Weather radar. And here, FDR, flight data recorder, QAR,
VHF.
and VHF.
3.
Well, center and right.
Oh.
But yes, 3. I'm going to put it in parentheses here, 3. Right? Aside from that, everything else has to go through the IOMs. Input, output modules. Okay? But, so that's all in there. But what's inside of these CPMs? Well, that's all the things we're going to talk about, or everything we've talked about. So we have QAR function. We have the ACMF function. These 2, right, make up the ACMS system, or airplane conditioning monitoring system. So the system is made out of one function, which is the ACMF function, and the QAR, which is a physical box inside the right? So this is ACMS, and it's composed of these 2 things. Then we also had what we spoke about yesterday, primary PDS, right? Which is the primary display system, right? Or you can think of it as a function, because the system is the DUs, but the function is housed in here.
Mm-hmm.
What else we got here? CMCF. So CMCF. So the function of us accessing the ground test, the oil consumption page, those are functions. That's software. It's housed in here, in this one.
Okay.
Okay?
Okay.
It's housed in here. So yes, the CMCS is a system per se, and the system is the function plus the map. Okay? And then, so that's up here. That's the things we covered so far. When we talk about out of flight, it's everything else. So flight management, thrust management. What else we got there? Digital flight data acquisition function. That's just basically a function that converts all the system airplanes into the FDR. Right? So the systems, how can I explain it? All the information from the aileron position, engine positions, from the EEC, it doesn't talk directly to the FDR. It can't. They don't talk the same language. So it goes through that digital flight data acquisition unit, right? So I'll just abbreviate digital flight data acquisition function. Flight deck communication and data communication. Data comms. Those 2 things live in here, right? 2 things live in here. This lives in here, okay? The only thing that lives in here are the little graphics, and in here, nothing lives in here. These are strictly, think of it as forks in the road. It diverts data where it needs to go, but everything else lives in here. Sorry, lives in these 2. Whether it's communication to these, flight management, all this, and the standard and basic. And this is the graphic. If you really wanted a breakdown of what goes where, here you go. Okay? This is what everything's inside here. Right? So the CMCF function lives in the CPM COM. The data conversion gateway function lives in the CPM basic. The flight management computing function in here. Thrust management in here. ACMF lives in here. And if it does, it's only in the left Ames cabinet for Ames 1. All right? And then QAR, digital flight deck, that's all in communications. In here, the only thing that lives in here is the primary display function and the way for it to get weather radar. And then the IOMs, notice they don't house anything. Nothing lives in them. They just direct information accordingly. So, for example, if it gets a signal from your thrust level actual resolvers, then it's like, okay, what do I gotta send? No, I gotta send the thrust management function. So I'm gonna send it from the IOM over to the basic. Oh shit. Sorry, me too. All right. That's Ames 1. Ames 2 has PCM, and all that is power control module. It just filters out. So remember, we used to have power filters in Ames 1. Now we have another one that controls the power. It's PCM. And the other thing that changes is that the CPM here is not called standard. And both the left and right now house the ACMF function.
Okay.
All right? And that's Ames in a nutshell.
Can't get any better than that.
I always find it funny how, you're supposed to teach this whole thing in 8 hours and you can reduce it down to just the board.
Yeah.
That's always the case.
We have this, but
Yeah, you have it, but if you want to take a picture, that's good too.
still have it.
No better. Right. All right, Virgilio, the only thing I was telling James and Dennis that you missed when you asked me to move the camera, and I forgot, is that all these functions we've been talking about, well, we talked about the primary display function yesterday. We're going to talk about the CMPF right now. The ACMS we're going to talk about later today, probably after lunch. All this stuff about flight management, thrust management, data acquisition, communications, that's all for tomorrow and Friday, right? But here's your Ames in a nutshell. You have 8 modules in Ames 1. Remember, there's Ames 1 and Ames 2, which is the updated version. Most planes you'll ever see is Ames 2. There's not a lot of planes living out there with Ames 1, but you never know for these fishy airlines. But in a nutshell, here you go. You have 4 IOM, which are input-output modules, 4 of them. 2 on the left, 2 on the right, in the cabinet. In total, between left Ames and right Ames, you have 8, because 4 on this chassis, 4 on the other chassis, right? What is the purpose of the input-output modules? They do nothing more than divert traffic, okay? All they do is receive any information, and they send it on its way. So if it gets an information from a hydraulic pump that something's wrong, well, then it'll take it and be like, okay, I'll give it to the CMCF function, which allows me to show a fault accordingly. If I want to show it onto ICAS, or rather, if I want to put it onto my ICAS, then it might have to send it some other place. So that's that. That's what the IOMs do. What do the other things do? Well, you have 2 graphic generators for every Ames cabinet. All they do is make them cute little pictures that you see on your PFD, on your ND, on your ICAS, on your lower displays. All those cute, colorful boxes and messages you get, they come from the GG. All of that is stored in there. The CPM communication, well, that has to do with all your communications, including, right, data communications and voice communications. And of course, the other communications we forget about is the communication for the airplane. So anything that has to do to the flight deck recorder, so the flight data recorder, the black box, lives in here in the CPM comm. This is the oddball. It's CPM basic, right? CPM basic houses these. So the flight management computer function, thrust management airplane, basically auto flight lives in here. Now, there's a CPM basic and a CPM ACMF, which is airplane condition monitoring function. They only exist in the left cabinet. So in AIMS 1, if you go to the right cabinet, you're going to see something called CPM basic. If you go to the left cabinet, you're going to see CPM ACMF. It is the same thing as the basic one with the added feature that the airplane conditioning monitoring function lives in there. What is the ACMF? We're going to find out later after lunch that it is what makes all your reports. Overspeed report, hard landings, so on and so forth. All right? Any information the airplane wants to give it goes through the IOMs. All the information, system information, anything. Except weather radar goes directly to the GGs. And for your CPM communication, your QAR, your flight deck recorder, and VHF, center and right, because those two are capable of receiving and transmitted data. And there you go. That's AIMS. That's a refresher for yesterday. Now we're finally going to go here to the central maintenance function, which lives in the CPM communication. Okay, so that's what we're going to do right now. That's what we're going to learn. And for lack of a better term, or for if you wanted to explain it quickly, all it is the map. That's all this chapter is going to be. How to interrogate the airplane via the map. All right. Is this on? No. CMCS, which is basically the CMCF function, right? So here's AIMS, CMCF function, which is basically the software that allows you to do all this, is basically the CMCS. The only difference is that you obviously need something to access that function. You can't just access it, can't plug yourself into the computer. So you need an interface, and our interface is, of course, the MAT, or the Maintenance Access Terminal. Or you can also do the same functions for the PMAT, Portable Maintenance Access Terminal, and for some airplanes, the LMAT, which is the Laptop Maintenance Access Terminal. The LMAT and the PMAT are the same. They're yellow. The LMAT is thinner. If your airline has a lot of money, maybe they pick the LMAT. Delta decided to get the LMAT, but they're the same thing. Some of them are locked away. Like Air France's, you saw that green thing, it had a key lock. That they have an LMAT because it's thinner. The PMAT is really thick, so it wouldn't fit in there. Most PMATs are fixed onto that floorboard, and so there's no chance of you, losing it, so to speak. But if you have the thin little green casing, it's because you have an LMAT, and apparently Air France locks it away. So the central maintenance computing system collects and stores manager data for most airplane systems, most of them, right? So if there's a fault on a system, how the hell do we access it? Through the CMCS. The MAT and the PMAT is our interface. That is how we are able to communicate with the plane. What are the functions? Fault history, input monitoring, configuration reporting, shot faults, engine balancing, PSEU. All PSEU stands for is proximity sensor electronic unit. Those are for all the sensors, the near far sensors on the door, on the landing gear, all that nice stuff. Air ground rigging and report generation. And that's the CMCF, the ACMF function we'll talk about. Now, I told Virgilio this, but I'll tell you guys if you didn't hear me. See this engine balancing? On the engine blades themselves, right? They have you have to balance them, right? And then they have the little weights, and depending on the number. One of the first things that ever happened to me when I was doing my class, I had a really, really strict teacher. And he was no fun, and he was monotone, and all he did was read off the manual. He'd have the laptop in front of him, and he'd be like, this is chapter, and that's how we talk. So I never listened to him. And towards the end of the class, I don't know why, or towards the end of this chapter, he would go through everything, and all we asked was like, can you please just tell us what we need to know for the test? Can you please tell us what we need to know for line maintenance? We don't need any of this. And the one thing he didn't tell us that he said, okay, I'll skip it, is engine balance. He said, there is no way you will ever do this. This is heavy maintenance. It's the only time you're going to do it. I come back. I'm living in Boston, or rather for a summer, I'm covering Boston. One of my first flights, I turn on the plane. The plane is overnighting. I come in the morning, I turn it on, has an engine balancing fault, a no-go item. So I go, no way. What? I didn't learn this. This is something I generally can say I did not learn. So I had to call London, and then the guy that, funny enough, that I was shadowing in the hangar, he said, first day on the job and you already messed up? And he told me, he goes, somebody forgot to put it, because once you put the new blades, you have to put the new weights. So if you want to put the new weights, for whatever reason this happens to you, you can do that through here, through the engine balancing, and then you go literally through every blade. You write down all the numbers, and then you go through every one by one, every blade position.
Wow.
Once it gets the information, then the engine, the EEC is happy, the vibration monitoring computer is happy, and on it goes. Yeah. So,
What are the odds, right?
yeah, and that's exactly what I said. I hated this guy for 10 weeks. I hated him. He would pick on me. He didn't like me. I didn't like him. The one thing he doesn't teach me, I get. So, it happens. So, what's the concept of the CMCF? What is it? What are we doing here? Well, again, I know this might seem like trivial, or this might seem like, yeah, I mean, of course. But back in the day when the 777 came out, this was new. The CMCF, the MAT, that was revolutionary. They're like, holy shit, the plane's going to tell me what's wrong with it. It wasn't just a fault or a little fault light and you had to guess what was going on, like the 57 or 67. 777 told you, no, this is what is wrong with me. Here you go. You need to fix this. So this was revolutionary. So what happened? You would get a message from whatever LRU. You'd get a message. It would send it to the flight deck. The captain would see it. They'd write it down in their logbook. You'd come in. You'd see it. Do you want to fix it? No, or you can't. You MEL it, right? If you're interested and you want to see what happens, then you go, yeah, I want to fix it. Let's see what happens. So you go to the MAT. First thing you do when you get it back, you go to the MAT and you go, let me see what's going on. Sometimes you won't have a flight deck effect, meaning you won't get a status message. Sometimes the captain's going to say that it came on and off in flight. Well, you can't simulate that on the ground. So what do you have to do? You have to go to the MAT, to the CMCF, Central Maintenance Computing System, or the CMCF function, and you're going to come here, you're going to go to line maintenance, and you're going to look at either existing faults, present light faults, inbound defects, depending on how much information you need, because every single one is going to give you a different piece of information. So you look at it. Then what do? Well, you click the message. The message is going to tell you something. After a while, you'll start memorizing messages, and you'll know what to do instinctively. But other than that, the point of this is so you can go to the FIM. You go to the FIM when your maintenance message, you type it up, it tells you what to do, and then you can run the test. Most of us don't even look at this. Most of us say, oh, there's a chapter 23 fault, let me go check this. There's a chapter 21 fault, let me go to the ECS mode. Or we re-rack things. But the purpose of this, in theory, is that this is exactly going to tell you where to go here, right? Get the maintenance message, you look at the FIM, whether on the computer or in a physical book. I haven't seen a physical book in a very long time. So you go on the computer, you check what the FIM message is, you do whatever you want to do, fix it or not. Can you fix it? Yes. Can you not fix it? You dispatch it. And that's how you do it. So that was what the CMCS was meant for the plane to tell you, hey, this is what's wrong with me, as opposed to like showing you a little light and now you have to guess, right? So it was meant to reduce guesswork, or the hard part of finding and the research part. It was meant to reduce that. Even further still, the 787 introduced the whole point of you looking at of you accessing the FIM on the plane, and the 350 took it even further, and now they have hyperlinks. So this was like the first rendition of all that. Right, so you have something called the Onboard Local Area Network, or ONIS. What the hell is the online? It's a fiber optic communication network, and all it is just basically a communication between your Ames cabinet and your MAT. That's all it is. That is all it is. The local area network, or the onboard local area network, all it is just a little mini network between you on the PMAT or on the portable MAT, either one, right? Accessing a BSU bypass switch units, then to Ames. That's all it is. It's just the connection between you and Ames. You and Ames. That's it. They're fiber optics. So that's all the local area network. What is it? It says it carries more data than wire buses, less weight, and electromagnetic radiation has no effect. Those are its benefits, right? But again, to be blunt, the onboard local area network, or ONAS, that's wrong. It's not ONAS. Yes, it is. Sorry, it is ONAS. Onboard local. Yes, okay, that is the acronym. ONAS or OLAN. See, that is not it. ONAS is the acronym for Airbus. So it's a 350. So you see where mine was when I wrote it. So I apologize. So it's not ONAS.
It's OLAS,
It's OLAN.
OLAN.
Yeah. See, I wrote it down in the notes, but I didn't write it on the title. So OLAN, and I wrote it here, OLAN. Onboard local area network. I apologize for that. Right? And again, all it is the communication network between you at the MAT or you at the PMAT and Ames. That's all it is. There's two cables, primary and secondary cables, goes to the VSU. Right, the OLAN moves digital between the LRUs for test, data, fault isolation, all that good stuff. What this is showing, that's the MAT, there's a router. What this is showing you right here is that on the overhead test switch, if you want to use the portable maintenance access terminal, you get power by turning on the test switch. So if you go down there, you're trying to turn it on and say, why it's not turning on, it's because the switch is not on. And then it's showing you here all the different connections that you have for the PMAC. So you have one at the nose wheel, one at the main wheel, one at the jack screw, and one at the flight deck. So you can connect the PMAC here. Okay. Oddly enough, you might be asking yourself, why do you have a connection for the PMAT and the flight deck? That's if the mat is not functioning. You can go downstairs and get the PMAT. But it's all there. All right. So that powers the mat, the ground switch on the P61 panel. Just showing you what the fiber optic networks, again, I got to fix that. It says ONAS, but it's OLAN, right? It's just showing you that inside the fiber optic, if you look at it, if you want to separate, you have five fiber optics. You have two fiber strands, a separator tape, an aramid yarn wrapping that, and then an outer jacket. And you see that it's that light, like pink, like that light purple, light bluish cable. That's what it is, right? You have two different types of connections. Here's just telling you, make sure you have a minimum bed radius. Don't sharpen it because you will break it. Here's just showing you that there's two types of connection. There's an A type, and it's for production brakes, not regular disconnected. Meaning, if you see this type of connector, you're not really supposed to disconnect it. In fact, that's probably where long harnesses meet each other. That's where it would meet, like bulkheads and stuff like that. This is the cable connection from the cable to the LRU. So for the actual box, this is it. You could disconnect that, or you would disconnect that a bunch of times. So this attaches to the LRU. The only thing that is showing you here is that in order for you to make sure that the connectors connect properly, and you're not just putting it any single way, there is a yellow band and a red band. And when here's another yellow band. When you put the connector, right, the receptacle and the plug, if when you put it in, this red band is covered 50%, right away, as soon as you put it in, without you even twisting it, as soon as it's covered halfway, then you know it's properly locked. If you put it on and you see the entire red band still, then you know it's not lined up properly. Does that make sense? So what I'm trying to say is you should be able to plug it in about halfway before you need to twist. If you're twisting right away, it's not lining up, don't do it. Right? That's all it's saying. So it's correctly, when the plug goes over the receptacle halfway, you look at the red band. If it's covered right away, halfway, then you know that it's properly aligned. If, for whatever reason, you're connecting the receptacle and the plug, and right away you start twisting it without even pushing it, then there's a problem. Think of it as a Canon plug. It's the same concept as a Canon plug, except that there's no actual, there should be a keyway. It says that there's alignment groove here, but sometimes, you know us, we find a way. So when you put in a Canon plug, you could put it in a little bit first before you start twisting it. Same concept, right? It's just showing you that there's an actual color band there to let you know.
Okay.
That's it. But again, you guys all experienced. It's not like you've never put one of the Canon plug before. Just showing you where the BSUs or the bypass switch units are up in the E&E bay, right here in the crawlways, up here, really hidden, and here's the router, really hidden. Ground switch interface, right? So P61 panel switch. What's going on here? It allows you for some tests, not all the tests, some tests you have to turn on the switch. Why? Because what you're actually doing is that you're moving which IOM you need to touch, you're connecting to. That's what's happening. Let me repeat that. The ground switch, right? When you have it in enable, right? Normally it's in normal, right? Meaning all these connections are open. When you hit enable, you bring the pole down, and what you're doing is that you're connecting it to a particular IOM, right? See that?
Yes.
That's what you're doing. Other systems you need to do the ground test for, notice, is the PSEU, which is the proximity sensor electronic unit. So if you need to do a check of the sensors, the near-far sensors, or you want to do a rigging check or check it or fix the rigging, you would need to enable the test switch. Right? So PSEU1 needs it, PSEU2 needs it. Your left card file, right? Your left card file, you need it too. So notice that in the normal position, right now it's not enabled. In the normal position, you inhibit this. If you want to test it or check the card files, you'd have to enable it. So there's certain card files that you need to enable it. That's what it's showing you. Okay? And of course, remember I told you that it also powers the PMAT. Okay? So aside from switching over to certain IOMs in the Eames cabinet, connecting to the proximity sensors, electronic units 1 and 2, and some of the card files, what you're also doing is providing power over to the PMAT. All right? So the systems that use the ground test switch, overheat detection, airfoil ASIPs, which is airfoil and cowl ice protection, better known as ASIPs. It's just anti-ice for the wings and the leading and the nacelles. That's what it's called, airfoil and cowl ice protection, ASIPs. Duct leak detection, air ground mode, hydraulics or HIDIM, and ECS, environmental control, and cargo smoke detection. Where's the cargo smoke located again? Which card file?
The gateway.
Thank you. ASG, airing signal gateway. Those are the ones, right? All the other systems have typically their own individual system card. So there is an overheat detection card. There is an ASIPS card. There is a hydraulic card, which is the HIDIM. There is an ECS card. There is a duct leak. This one don't. The smoke detectors for the cargo do not have their own card. They live within the airing signal gateway or ASG. How many ASGs in each cabinet? In each file cabinet? 2? 2. Very good. There's 2 ASGs. So 4 in total between the left and right. Very nice. Keep this diamond. Right, PMAT, nothing crazy about it. It looks like it's out, but it's typically recessed, so you wouldn't see this back portion of it. So, but you know, nothing crazy. You have the actual display, a light sensor, the brightness control knob. Remember, you have the Mac cursor control device. For very old ones, the one we went on today actually has this old ball and track. And down here, you have a flash memory module, basically for you to put a floppy disk or a hard drive. Why do we need a hard drive or a floppy disk? Well, if you have to upload or download anything, you probably do it through the floppy drive. The cabinet attendant control panel, also the CACP and door 1L, also has a floppy disk drive. But this hard drive right here, I was explaining to Virgilio on the flight deck. Say, remember yesterday I told you if you disconnect your battery, right, and you have no power to the plane, you completely kill the plane, take out the battery, you're going to erase all the memory or most of the memory in your CMCS. So all your fault history, all your leg history, erased. So how do you save it? You don't want to be the guy to be known as oh yeah, I disconnected the battery and erased the whole history of the plane. So you download the fault history first, then you do the battery, you do whatever you got to do, and then you put it back and re-upload it onto the PMAP. This is what I was telling you also, that if you want to remove a real serious fault, you can disconnect the battery in hopes that it goes away, but at the same time, you run the risk of deleting everything else.
Mhm.
So that's what this is for. So if you want to not only upload, download databases, right, you can also download the memory first before you delete it. All right? So it's like a backup drive for you to dump stuff. 787-350 gets it directly wirelessly. This is before wireless, so hard drive has to do. Yeah, this is that. And I have a video of how to download stuff, so we'll see that momentarily. Right? That's the new PMAP. Sorry, that's the new map. Notice there is no cursive control device touchscreen. Okay? Right underneath that, you have the keyboard connection. So the keyboard does two things. Standard keyboard functions like typing things up if you need to. And if, for whatever reason, your CCD device doesn't work, you can use the arrows on the keyboard. Right in there. And here is a video.
The latest version of AIMS 2, there will be a new maintenance access terminal in the flight deck. The first thing that you will notice is that the trackball used for navigation is no longer installed. Also, the keyboard has been removed. The new mat uses touchscreen navigation. There's a row of buttons across the bottom. This is the power button. This button brings you back to the main menu. This is the button to select the virtual keyboard. This button rotates the image on the screen from landscape to portrait. This is the dimming button. And this is the button used to increase the brightness of the screen. On either side of the mat, there are USB ports. Use this button to power the mat. It'll take some time for everything.
It's Windows, so it takes like 5 minutes to turn
When
on.
the screen shows, press enter. From here, you can navigate the mat functions. There are a couple ways to access the virtual keyboard. From the main screen, you can select the virtual keyboard tab, or select the virtual keyboard button as shown here. To close the keyboard, tap on the X. Selecting the AIMS button will take you to the familiar
I
menu.
personally like the old map.
Select on
Yeah.
the maintenance tab,
Way better, faster, you can scroll quicker.
and now you can navigate the usual maintenance options.
See, even in that video, you see him struggling. Right? And so that's how you run your ground tests and stuff like that. But that's the new map. It's all touchscreen. It's very sensitive. Not even sensitive. You have to press the screen hard. It's harder to scroll, but whatever.
You can look at the mat.
He's not on the mat. Right now he's on the portable mat.
Drop-down function. When you initiate the mat operation, you'll get a toolbar at the top of the page, and on the upper left, it will identify line maintenance. By selecting it with the cursor, gives you a drop-down menu, as you can see here. The first item we're going to take a look at is inbound flight deck effects. Of course, inbound flight deck effects.
Sorry. I'm gonna try to adjust the camera. It doesn't look good. Hold on. Oh, man. Worse. A little bit better. That light is too bright. So that light is too bright.
Which way?
That light. Oh, light projector. That's what's like causing a.
How about put it behind the projector?
Nope. It's the fact that it just shines. Like if you look at it, it shines on. That light shines here too bright. Let me see something. That's still gonna show.
Maybe you could dim it a little.
I did. That's the problem. So, because I went here.
Bring it all the way down.
Still too bright, and it doesn't help us. Yeah. This sucks.
How about if we get a
That's what I'm gonna do.
table, man?
That's what I'm gonna do.
Maybe try this.
See how the light just shines too brightly? Even if you're down here, if you go an angle up, no, nothing.
Why does it look like that?
I really don't know. Let me see.
Let me check it another picture. Yellow is bright. Yellow is very bright.
Maybe it's just the video, this video.
No, it's like that for every video.
Let's see.
Let's see. I mean, it's nice that you have it up here, but not better. Not really. You get closer.
Because when I was doing the remote, you guys had
That's a little bit. That's a little bit better. Because see how it gets shiny when you're like straight, it's shiny, but when you look up,
Yeah.
the reflection of the light don't hit it.
How about if you put it on the floor?
So
Too low.
right here, this is about the height you need. Right here.
How about here? Try that?
Nope, too low. No, the test is pretty good. Test looks like it's probably the best option, but right there.
All right, can we stay better?
Yeah. Can you get a tape? Oh, I got tape. I got tape. I think this just one is enough.
Enough?
Yeah, that's enough. Just be careful there.
Oh, these are not better.
Better, right? That looks good.
Feel better?
Looks way better. With that, Virgilio. Virgilio, what do you think? Is that better?
All right. How are we looking?
Did he study at home?
I'm sorry?
Did he study at home?
He's.
or-
I think he's home. Still too bright.
Maybe.
No, that if you turn that off, it makes it worse.
How about there? Right there, maybe. Maybe for the videos, you gotta have all the lights on, maybe?
Maybe.
Ask him if it's better like that? Put the video on.
Take a look at the mat. utilizing the
Look at
line
This is
maintenance
better.
drop-down function.
Right, so videos with light on. Right, we'll do that.
Video lights on. All right. Let's see what this guy has to tell us.
What does BSU stand for?
Bypass switch units.
Bypass switching.
Take a look at the mat utilizing the line maintenance drop-down function. When you initiate the mat operation, you'll get a toolbar at the top of the page, and on the upper left, it will identify line maintenance. By selecting it with the cursor, gives you a drop-down menu, as you can see here. The first item we're going to take a look at is inbound flight deck effects. Of course, inbound flight deck effects are defects that the aircraft recorded on the initial flight into your station. In the event that there is items that were recorded, you can see how they're listed basically with important information in two separate columns. On the left, you'll see the identification of FDE, flight deck effect, and what is the flight deck effect, either an advisory or a status message. And on the right column, you can see the status of that message. Is it currently active, not active, or latched? As you can see with the selection here, we're choosing to look at the maintenance message that has been correlated to a corresponding flight deck effect. By selecting it with your cursor, you see how it highlights it, and then select the maintenance message data button below. And this pulls up a page that gives you more detailed information about that maintenance.
Real quick. So yes, you click the message, then you go over to more maintenance message, and it'll give you more information on it. Give you the maintenance message itself, whether it's active, when it occurred exactly. So it tells you the phase occurred at 14:22 Zulu on the 26th of February, 2018 during engine start. Great. This box right here, recommended maintenance action, I would say 8 out of 10 times you won't get anything useful. All it's going to say is, please see FIM.
Mhm.
In this case, it tells you probable causes, the CPM GG and the right aims and the right aims chassis. And if you scroll down, it'll give you other stuff. But even maybe 9 times out of 10,
I
it's
don't
going to
think
say.
I ever seen one.
Exactly. So there you go. It's always going to say, see the
CFIM.
FIM. See FIM. See FIM. And you know what? The airline probably has the option to just write that so that you don't blame, oh, that's what it told me. No, just go to the FIM because they can control that better than they can control this. So it's there, but 9 times out of 10, it will not give you any useful information.
This message. Now, the maintenance message, you can see where the finger is pointing. It's identifying currently it is not active. But the maintenance message number that's identified here is what you could use to go to the FIM to figure out the task. You'll also notice in the recommended maintenance action block that it gives a list of possible causes.
Everything all right?
This is not associated directly with the FIM, but it could give you some important information, such as you see here, identifying you to do this ground test to unlatch the fault. It identifies what type of test and in which module. If you were to scroll down further, you can see that this fault is also correlated to other flight deck effects being shown in the aircraft. This lets you know that by fixing this problem, these other messages should correct themselves. You can navigate by going back, taking you back to your initial selection, and then you can continue to scroll through the other options. Once again, taking note of the flight deck effect, the correlated maintenance message to that flight deck effect, and then the status. Next, let's take a look at the existing flight deck
I prefer this one.
Now, existing flight deck effects are displayed in the same format that we just saw. But you'll notice how their flight deck effects, some of them may not have a correlated maintenance message with them. That's because these are more situational.
And that's why I like it more. It's more condensed. You don't have so much information.
Is turned off. But you will also see flight deck effects
I apologize.
that do have correlated.
I prefer the other one.
The other one
messages.
is what I meant to say. That's the other one. This one will tell you if you have your pumps off, like it says right there,
It comes
it's
out.
going to show you it's in the video. Yeah, like your pumps off. Okay, I don't need this. You're right. Sorry. The inbound flight effect is the one that actually that they saw.
Once again, even from this selection, you can select a maintenance message, and then going to your maintenance message data, pulling up that same page, identifying your maintenance message number, who's seeing it, the possible causes, its current status. You can also scroll down.
This guy's 2
and
for 2
because
for recommended
it is
actions.
latched, the recommendation
Like you say,
is
it's,
to do
it's
this
most likely an
test
airline.
to unlatch
I'm
it
sorry?
It's most likely an airline
to see
option.
what the
Oh,
results
100% probably.
This one too?
Huh?
This one too?
Yes, all the correlated flight effects. It will show the
Now,
boxes
take a
there,
look at
but
performing
information won't be in
ground
there.
tests.
Oh.
Now, you saw an example of some ground tests that were recommended for us to do to unlatch a fault. When you do the selection for ground tests, you can see how they're laid out in ATA code. Take note that there are more than one selection per ATA.
And some of them are just
Usually,
weird
the
things. So, like if you're looking at
is
the
guiding
batteries,
you to a selection.
I'll try to remember. I think the batteries for the PSAs,
is doing
might not
so
be
after
in
replacement
24. They
of
might be in
component.
27, even though they're
Or
technically
in
batteries
the
and
example
electricity. See what I'm saying?
that we
So
saw
there's sometimes
earlier,
it's if you don't find it in this chapter, you got to look at other chapters.
to unlatch a particular message. Now, we've scrolled through all of them, and we'll make a selection here for the hydraulic system. Now, you'll notice that when we do so, even though there are 3 test options, only 2 of them are operable because we cannot select a system test, but we can select operational or LRU. We've selected operational test, and now the various tests available to you are visible on the lower block, and making that selection and selecting continue now brings you to the specifics for operating the test. You'll notice that there is a description and some information about the time involved. Also, let's list you some airplane effects, such as your hydraulics will be pressurized. Scrolling down, it tells you some of the prerequisites to do in order to run the test. Once you have done the prerequisites, you select continue. And the aircraft will then give you a ready when it's capable.
Just like on the
of starting
787,
the
you'll see sometimes inhibited.
select it,
If it's not, if you didn't do all the necessary things.
and you can see how
Does it
it
tell you
now goes to
What needs to
operate.
be?
No, see, that's a 787 thing.
Okay.
See, 787, they thought, they're like, oh,
The
let me
test
tell you what's
will
wrong.
let me
If
tell you
not,
what's wrong.
you're going to have to go back, read everything, double check.
To operate
350 is nice too.
which
What happens
test
is that it's highlighted just like a checklist.
just
So it'll tell
remember
you
to be
what's
patient.
missing. So on the page before, as you do everything, it starts going
The test
green,
is
green,
in
green, green, green.
operation. You might
That's on a
get
350s.
warnings
Beautiful. But yeah, here you gotta guess,
And then
or at
when
least
the
go back and
test is
redo the list.
completed, It'll show you this page, identifying its calculating results.
You do get a status message
Once
for him when you
again,
turn on the.
be patient.
Yes, it will say ground maintenance.
And upon completion,
What does it say? It
it'll
says
either
ground maintenance.
identify
Ground
this
test
test passed.
No, but ground test switch? No, is that the status message?
If
No.
it is a fail,
I got
it
it.
should show you a correlated maintenance message identifying for the reason for the failure, and you can take that to the FIM to do further troubleshooting. Now, the next one we'll take a look at is system configuration. Now, system configuration, you can see it too, has items lined up in ATA format. And system configuration will provide you with information in regards to the hardware or part number for some of the critical items in a particular system, and definitely provide you with the software that can be loaded into the component if you have to replace it. Now here we've done a selection for ATA 26 for the engine fire detect cards. You can see it identifies 2 of them. It does give us a part number and a serial number identified for the cards. You'll notice these cards do not require software to be loaded to them because it's not identified. We can select a new ATA and select a different item.
Browser.
In this case, we're going to do ATA 21, Environmental Control System. And you'll notice now it does identify the ECSMC miscellaneous cards, their part number, but also the OPS and OPC software part number that you would need to load into a particular component. Now, grant you, this is real-time information. So if you had replaced that component and that software loaded to it does not match your aircraft loadable software list, you would then have to load the proper effectivity to the aircraft. Here we're going to take a selection for ATA 31 for one of the Ames cabinets. And the Ames cabinets, being made up of several LRUs, we'll be able to see these LRUs listed under system configuration. You'll notice here, starting out with the CPM COM, it gives the part number and then all of the software that is loaded to that current component. Then we'll identify the CPM ACMF or standard and the software loaded into that component as well. We have 4 IOMs in a particular cabinet. They do not require software, but you do see the part number identified here and their identifier. And you do have 2 graphic generators in each cabinet. Here you can see them listed and the software associated with their operation, such as OPS, OPC, and for the checklist software. So this should identify for you the various tabs in the drop-down menu for line maintenance on the map.
All right.
You can look at the map.
Right, and this is again going back to where the PMAT receptacle locations are, right? That's it.
You might want to show the letter for it.
Right. I forgot about that. Thanks. And then remember, the left CMCF function is the primary, the right one is the secondary. It's fine. You can use it 3-to-1, but normally it defaults to left. Sometimes, however, if there's something wrong with the Ames cabinet, then you want to switch it manually on the PMAT and go to the right. Could happen. The right CMCF is the primary. If the left fails, switch to PMAT. Wait a second. That says the complete opposite. Oh, sorry.
If
all right, let me that. The right CMF is the primary if the left one fails. So left one defaults, the plane always chooses the left one. If the left one fails for whatever reason, that CPM is probably out. Remember, it lives in the CPM communication. So if CPM comm goes out on the left Ames, it's going to automatically switch over to the right Ames. Or you can manually do it through the map. You can choose where do you want to access the function, left or right. But primarily, always the left. And that's it. Again, remember, first, whatever information you're getting, whether that's from the airing buses, airing system buses, remember 4 of them, the Ames intercabinet buses, 4 of those, whether it's information from the flight control buses, which are 3, total of 11. If you're getting any discretes, for whatever that is, or if you're getting anything from 429 buses, like the LRUs, they all go through the IOMs, all of them. One of the differences, right, it's not here. One of them is the avionics LAN that goes directly through here. And that avionics LAN is the local area network, which has to do with the PMAT and stuff like that. So that's how you're communicating, right? The PMAT goes directly to the CPM comm. It's not like you're going on the PMAT through the IOMs, then over here. Okay? You're doing is MAT or PMAT directly to the CPM itself. That's what that is, the avionics LAN. Right? So remember, all information goes to the IOM. The IOM is the one that sends it to the CPM through a backplane bus. Right? It's just like a local bus, if you will. Comes in here, it determines where it needs to go, then it sends it over here to the CPM. The opposite is true, right? If the CPM is doing something, right, like wants to run a byte test or whatever it is, right here, ground test, you want to do system operational test, right? Whatever you want to do, then it works the opposite way. It goes through the backplane bus over to the IOM, and then the IOM sends it to wherever it needs to go. Right? So always the IOM is the point of contact, with very minimal exceptions, one of them being the FDR, the QAR, VHF, sensor and right, and the avionics LAN. And this is just everything that's here. You have a redundancy management. You want to do a byte test of the CMCF itself. You have a byte test, power-up checks, and failure detection. Right? That's why it takes so long for the airplane to turn on. Or when you reset the aim switch, it takes forever because it's running through its own, every CPM is running through its own checks. Fault data processing inputs, inhibits values for fault reports because there's some times where you don't want to get a report necessarily. So like if, I don't know, if you have a hard landing, it doesn't spit out the report right away. It spits it out once it like shuts off its engines and it gets to the gate, right? So all of those inhibits are in here. Correlated FDs and maintenance messages. If you want to show the pilot something, like there's a fault, there's a status, there's certain flight phases where I won't give you all that information. Again, all that is in here. What else do you have here? Loadable diagnostic information. Of course, that's the stuff you can upload and download. Your ground test lives in here. Flight leg and flight phase calculation. Remember, this information is controlled by what phase of flight you're in. System config, input monitoring, onboard engine balancing. Those are all those things I told you. All those menus, here they are. Ground rigging, calibration, special functions live in here. Interface protocol, where it sends everything, 629, 429, all the basically the ways it can communicate. AMI, airline modifiable information. That's that information like we were just talking about. If the airline chooses not to put any probable causes and stuff, it's probably there. The report generation function lives in here. shot faults. This is everything inside that CPM. So if you're ever curious what's going on in here, here it is. All right. Flight leg logic. Okay, so where's it start? Where it's so transition inhibit. These are the acronyms. TI, transition inhibit, transition enable, and flight leg transition. So we got to look at where the hell is TT. Where's the flight leg start? First engine start, right? It's inhibited basically from the time you start your engine all the way to when you take off. Right around takeoff. Those are vital times. You don't want to be getting status messages and nuisance message advisory when you're taking off, when you're trying to focus on the PFD. There's some that will, right? There's some that override it, like the WEUs or warning electronic units. If there's a fire, you're gonna want to know, right? So you can abort takeoff and stuff like that. But anything that has to deal with the CMCS, like a fault message or an advisory message, those are inhibited until necessary, right? So that is what is known as the transitional inhibited. Once you get to TE or the transition enable, that's when you can start seeing the maintenance messages, the advisory messages, and all that stuff. You do your flight leg, right? And then again, it stops when you shut off your engines. That's your leg, right? There's a certain way they number them. Flight leg 00 is the current leg, or more specifically, the flight that just happened. That would be known as 00. Then the one previous to that is 01, and it works itself backwards. But number 1 is not the first flight leg. So if you wanted to know what just happened when the pilot said, "Oh, I saw a status message pop for 2 minutes and then it went away," you wouldn't look at flight leg 01. It would be flight leg 00. That make sense? That's how you start counting. You start from 0, not from 1. Right? And it's just showing you the flight leg enable. So your parking brake is released, your engine takeoff thrust, and your ground speed over 80 knots, or you manually enabled it, right? And then that's your inhibit. So manual inhibit. You can inhibit it if you want to. And that's because, remember, if you want to run your engine on the ground, right? You want to run your engine on the ground, you don't want to start a new flight leg. You want to invert it. You don't want to push back all this data this way. So rather than doing that, you can manually inhibit it. I think there's a video here showing you. I know I showed Virgilio on the flight deck when you guys were upstairs. Right? That's the last leg. During a ground engine run, the flight leg logic will transition to the next flight leg, thereby pushing the faults back one leg. For maintenance ground run, disable the flight leg through the maintenance, extended maintenance, maintenance enable, disable. I brought this up earlier. Let me bring it back down. Right? So again, if you're going to do an engine run on the ground, you are going to move the flight legs back. You don't want to do that. So what you want to do is inhibit it, run your engine, and then shut off your engine and enable it again. All right? What's this? Should be a video. Yes.
Hello.
Hi.
Do you know that when you start the first engine of the 777, the flight leg changes and the central maintenance computing system of AIMS collects fault data in that new flight leg? This task will show you how to use the maintenance enable disable function of the central maintenance system to make a separate flight leg for engine run data. And this procedure is used to ensure the fault data from the engine runs is not in the same flight leg as the fault data from the subsequent flight. Let's perform the task to enable and disable the flight leg on the map. Go to line maintenance, extended maintenance, maintenance enable, disable. Select that, and it brings us up to this page. Now first, what we will do is disable the flight leg. This way, no flight leg will transition while starting the engine. After we've completed our engine start or run, we will enable it. So we will select flight leg enable, and this puts it back to its normal position. If for some reason you forget to enable it, it will automatically enable itself during the next engine run.
All right. So if for whatever reason you forget to enable it, once you take off, you do this. Cool. And these are the flight phases, right? We don't have to memorize them, but you got power on, engine start, taxi out, take off, initial climb, cruise, descent, approach, go around, flare, roll out, taxi, shutdown, and maintenance. Right? The logic includes you can only be in one phase at any time for obvious reasons. A flight phase remains active until the conditions for a new flight exist. All that logic lives within AIMS, right? Or in the CMCS function. Maintenance has the highest priority. So flight phase maintenance has priority over all of them. The next one in line is ES, which is engine start. Then after that is SD, which is shutdown. Then after that, go around. And lastly, the AP and FL, which is the approach and flare, respectively, are the ones that have over the center. That's yours. Do I have to memorize it? No. The only thing I would memorize is that you can only be in one phase at a time, and that's obvious. You can't be like, let's say if you're in this transition point, if there's a fault that happens here, it's going to pick one or the other. It's not going to say both. And the last thing is that maintenance takes precedence over all of them. All right. So CMCS correlation. What's going on? So fault issue here at the LRU, finds the fault, sends it over here to the CMCF, right? More specifically, it lives in the CPM com, right? So what's going on? Is it correlated to a flight deck effect? Yes. Correlated maintenance message to the flight deck effect. Do I store it? Yes. So on and forth. This is showing you the logic. Is it correlating to a maintenance memo? If it is, I'm not going to obviously show it to my primary display, right? Maintenance memos, pilots don't care about that. Even less so, right? Because the maintenance memos are important for us, line maintenance station. Does it have to be for a scheduled maintenance test? We don't even see that unless you go into the CMCF function and you look and you go to shop maintenance or shop faults and stuff like that. So unless you're looking for it, we won't even see these. So it's just showing you the level of priority. Flight deck effects, obviously for the pilots when they're in flight. Maintenance memos or maintenance messages for us on the ground. And then lastly, but not least, scheduled maintenance. And that's, again, for maintenance basis. You would actively have to go look for it. Okay? So again, and it shows you where to send it. Should I send it to the present leg faults and fault history? Do I send it to existing faults? Do I send it to inbound flight defect faults, present leg faults, fault history? These are all the menus. Right? Where do I send it to? And that's all this is showing you. Is how, depending on the message it receives, right? It's going to come this way. Cool?
Coolio.
Right? So main menu, we all seen this. We're going to keep looking at it. As many as 3 technicians can use the CMCS at the same time. So Dennis can get the map. Maybe James is over at the front and they did the upload and he's over there on the lower display unit. And I'm somewhere on the PMAP downstairs. We can all look at it, except that only one can use it at a time. Boeing 787 is the same way, right?
I'm sorry?
The 787 is the same way, right? You could be looking at one test, somebody else can be doing the same thing, but you can only be using it one at a time, right? You can only run one test at a time, yes?
Only one
You can only run test. Yeah.
I wasn't sure about that, actually.
The 350, you can run multiple tests. So you can be doing hydraulic tests.
No, actually, you could do more tests, I believe.
On the 787, you can run multiple tests at the same time?
Because there are some that you have to start a test before you start the other test.
Oh, yeah?
Yeah.
Okay.
On the air conditioning, you gotta start the CAC in order for you to run the.
Sure.
Yeah. So.
Okay. And it says you can also use the PMAT to use the CMCS and ACMS function.
To gain access to the mat on the 777, when you walk into the flight deck, look to the right, just behind the first officer's seat, and just outboard of the first observer's seat. And you're going to see the mat there, basically a computer screen with a trackball. And notice here we're going to go to our onboard maintenance selection using our trackball and the left click button. That's going to bring us up to this page. It shows us the main menu across the top and also shows us which CMCF is in control. The first menu we're going to look at is under extended maintenance, the data load page. This is where you're going to go to perform any data load on this aircraft. The next menu we're going to look at is under the line maintenance selection. We're going to go to inbound flight deck effects. This would pull up any inbound flight deck effect, any flight deck effect that occurred on that inbound flight. In this example, we don't have any available. This is where you would go to see those. Another selection in line maintenance is existing flight deck effects. This is going to pull up any existing flight deck effect currently on the airplane. Some of these could be from a normal engine shutdown, but some of them could actually be problems on the airplane. If you notice to the right, there's a scroll bar. You always want to scroll down. This is going to allow you to look at all the information on that particular page. And this is going to be the same for any page in the mat that has the scroll bar. You can see as we scroll down, it's going to give us access to all of those flight deck effects. The last item we're going to look at, or the last selection, is ground test. It's also found under the line maintenance selection. It's going to be based on ATA order, and this is going to allow you to perform any ground test or any bite that you may need to perform on this airplane. So once again, just a brief overview of the map and some of the menus that you're going to run into.
All right. So again, line maintenance has these. Another video? No, I was just showing you how it looks like in real life. So, right? That's how it looks like in real life, and that's the new map. Extended maintenance menu has the present link faults, existing faults, fault history, data load, hardware drive, hard drive, maintenance planning, and then maintenance enable disable. Right, that's how it looks like in real life. You got these other functions, such as other functions, right? This is what I was telling you, where you would get all the other, you have to do the engine balancing, shop faults, PSU, air ground rigging, and this is where we would access special functions. It would be in other functions. And then the help and report screens, which don't really do anything for us, except for the report. If you want to print something, that's where you would go. If you want to print like test pass, that's where you would go to report page data, and you send it to the printer. Right? All right, and again, we don't have to really go through this. You guys have all seen on the 787. Well, you have, Virgilio. This is just pretty much self-explanatory, right? This is the box. Here's the scroll bar, just like on a web page. You scroll up and down. You can slide the slider if you want, except on the touch screen. This doesn't work. You'd have to go like this. The good thing with the cursor ball, you can do it like that. This is an exclusive selection. This is, you almost never see this. Almost never see this. There's very specific things you can see that. This is your cursor. It's a little cross. If you click something and you're running a test, you get a little watch. Some things you can write notes in, particularly when you're in other functions and you're doing shop reports and stuff like that, and you have to make notes. That's where you make it. For us, I've never done one, and I don't expect anyone here to ever do that. It's not like the 787 that if you want to lock out a breaker and you put a note or an MEL. We don't do that here. Continue. If the button's available, it's going to look like this. It's going to be whole. If it's not available, it's going to be see-through, so you can't touch it. So they'll have a white background or it's see-through. And then here's the pull-down menu. All right, and it's just going to keep going, and it's going to show you. So if you're in inbound flight defect, this is all the stuff. It's got basic airplane info, like the tail number, the Reggie, the flight number, the time the leg started, what the date was, and where you got the information from. In this case, it looks like it came from the left CMCF. Remember, the left is the priority. And if you ever fail, it goes automatically to right, or you can switch it yourself. And again, it's just showing you a different thing that's there. Obviously, it's going to show you what the FDE summary was, or how it looks like, the name of it, the fault code, and the maintenance message. Remember, when we go to the FIM, you can search it up through two ways. You can look it up through the fault code, or you can use the maintenance message. I always use the maintenance message. Sometimes the fault code is good, because the fault code could be the same for multiple maintenance messages, and then it's going to ask you for the maintenance message. That's why I go directly to the maintenance message, because this could have a bunch of different ones underneath it. This is very specific to this exact one, and this one happens to be rad out transceiver, has an internal fault. Probably have to change the box. All right. And again, it's just showing every single display. Remember, this is the one I told you. That'll tell you the probable causes. It might even tell you recommended actions. Again, you'll always see the probable causes. You'll almost never see recommended actions. They'll just say CFIM. And then here, this is really good too, correlated flight defects, because if you have a bunch of inbound flight defects, you can see which ones are correlated and caused by a major one. Like the video said, if you fix one, you should, in theory, fix all the other ones. What I want to show you here, nothing. This is just showing you when you want to select the box. Again, even though you have 3 options, you have a system test, an operational test, and an LRU replacement test. Each one does a different function, but typically you're going to want to use a system test. But if there is no system test, then it's going to be like grayed out or see-through, and you can't click it. So the plane will tell you what you can and cannot do. Now it's going to explain to you what each one does. So it says a system test contains all adjustment specifications and tolerances to maintain the system or unit's maximum efficiency. An operational test determines only that a system or unit is operational. These tests require no special test equipment. And last but not least, an LRU replacement test determines only that the interfaces to that LRU are operational. So think of it as the general system, right? Hence the name system test. So if you want to make sure the entire system works, you're going to run a system test. If you want to check that an individual component, like a pump, works, you're going to want to check the operational test. And if you did any replacements, for example, you changed an IOM or you changed the graphic generator, something along that line, and you want to make sure it's actually speaking to the whole system, you would do an LRU replacement test. Again, we all do this. We're all guilty of this. We just go straight and we run a test, whichever one we like, whichever one we do. In reality, you go to the FIM or you go to the maintenance manual. It'll tell you what test to run, right? But most tests that you're going to run for a latch message is a system test, right? You wouldn't do an operational test to unlatch a fault most of the times. I can't say definitively because I'm sure there's always an oddball one out. What do we got here? Again, this is just showing you another dialog box for system config, right? So if you want to see what part number or what software is uploaded to a specific thing, you would look here. So if you want to see what the software for the AIMS CMCF is, so look at this. This is another thing. AIMS is part of Chapter 31. But if you want to look at the flight management computing function within AIMS, you have to go to 34. So this is one of those good examples, right? Mm-hmm. So you might think like, oh, I'm going to go check out if the software is fine. And you're on 31 and you can't find it. That's probably because this function, because it's part of flight management and Navi, you go to 34, right? And there's a bunch of scenarios like that, right? So if you want to do AIMS, it's Chapter 31, but if you're going to check the CMCF function, you go to 45. See that? And there's a bunch of them like that. All right. So in this case, this one is this flight management computing. Present light faults, same thing. I'm not going to go into all details, but again, you click here, and then you can check the maintenance data, so it can give you further information based off that issue. Existing fault.
I like to use that one a lot.
That one's good too because it currently tells you what's going on. Mm-hmm. And it clears up. Notice that the menu here is much smaller. Mm-hmm. The reason it's much smaller is because it's not like the other one that's going to give you an option of looking at every single ATA. It's just going to tell you the ones that are existing, the ones that are currently there. So if you don't see your chapter in there, then you know you're good. That's a quicker way to see it. This one is good too. Yeah, you're right. Fault history, again, you can look at the legs of when something happened. Remember, leg 0 is the current leg, but even more accurately than saying current leg, it's the leg that just came in, so the inbound flight. And then it works its way backwards. Okay, this is what it looks like when you're going to do a fault history and you're going to load it onto a disk. Move the fault history data to diskettes before you disconnect the main battery, because when there is no power on the airplane, the hot battery bus provides power to the static random access memory, or the SRAM, that holds the fault history, right? So the hot battery bus is what allows you, when you shut off the plane, or when you turn it on, how does it still remember what faults were existing? Through the static random access memory. That's why we power down planes. Because what you're trying to hope to do is erase some of that messages, right? If you erase it, then you know it was an intermittent fault, or it was just a little glitch, or the RAM just decided to keep it. When it comes back, you know it's a serious fault, right? But if you are going to disconnect the battery, again, please download it. Don't be that guy that they ask, why the hell is there no other previous flight legs? So you would want to download it.
I had a flight control assist, but
Oh, yeah.
it cleared.
You go. Yeah, they say, why the hell is there no memory to the plane? Be like, it's either that or it would have been grounded here because you had to send me a box. So you pick. You're right, though. Right? And then it's just showing you how to download stuff, and it's a video how to download it. So
If you have to replace one of the components that are in an Ames cabinet, you will need to load software into the new component. You will manage this through the Mac. Both the ERs and LRs will now have all software for the various components updated when the nav database is updated. The software will be stored on the hard drive for the Mac. The ER's mat will have a touch screen to navigate to the data load option under extended maintenance. The LR will have the traditional mouse trackball to navigate to the same location. Looking at an LR mat, we'll use this as an example to show how to load software to a component in the Ames cabinets. The software will be the nav database to go into a CPM standard. So you can see we're going to go to extended maintenance, data load. From this page, we're going to do the select destination. And because we're loading into Ames, we'll look for ATA 31. You have the choice left or right. We'll choose the left Ames. In doing so, you see how it shows you all the components in that cabinet that are software loadable. Because we're going to load the nav database, that'll be located in the CPM standard. So I'll make that selection here. Once selected,
notice he was talking about Ames 2, and because it's Ames 2 because he's talking about standard. But notice that software, it doesn't, or the CMCF, the way the airline Delta in this case uploaded it, they didn't correct this. Mm-hmm. See that? They didn't correct this. This should have just said CPM standard because it's Ames 2. So if it's Ames 2, there's no reason for this because this substitutes it.
He's using Ames. He's using the old one.
So the PMAT has nothing to do with Ames cabinet.
Okay.
Okay. The PMAT is the PMAT.
Okay. So
you can have Ames 2, like we did today. Perfect example. You saw the little modules.
Right.
Ames 2.
Okay.
With an old mat. Okay. So they have nothing to do with one another. However, this should have been erased. And it should just say CPM standard.
Okay.
That's all it should say. Right? Now, why did Delta not delete it? Many things. Maybe it's an oversight. They forgot. The other thing, maybe they still have Ames 1 lying around. Even though in another video, I think that guy said all the Delta planes have been updated to the Ames 2. Maybe. Or, so again, or maybe they, like I said, it's probably an oversight. They probably didn't update the CMCF function. Okay. But typically, it should just say CPM standard because if this is Ames 2, there's no such thing as ACMF now.
And I see that they're only loading on the left side, right?
Because he clicked left.
Right. Okay.
So this is all the left stuff.
Okay.
All right. Let's continue. But I just wanted to point that out, that it shouldn't say that. Because that's only for Ames 1.
Choose Add. See how it populates under the selected LRUs box, the component. Go to Continue. Brings you back to your page where you'll now be able to select the source. And so in this case, we're going to select the hard drive. And when you have the hard drive selected, you then need to find your software on the box down below. In this case here, we've selected the new nav database software. Select add. You can see how that now populates in the upper box. Go to continue, and it'll take you to your main page. Then you can select start. Now you see reference as to the conditions the airplane needs to be in to perform the data load. Select continue. It'll go through a summary bar to show you the loading of the software. Upon completion, you'll see where it displays that the software is complete. And you can see the nav database part number under the component selected.
All right. So I guess that was it.
If you have to replace,
So, right? And it's just showing you now the hard drive menu. So I got a video for that. So.
First of all,
Anybody want to turn on the lights on the video?
CNCF is active. Starting with onboard maintenance.
I don't know if you can see
We're
it.
going to go to extended maintenance. We're going to go to some hard drive software and part number management. And this is how I'm going to find some, going to delete some old software in here. And I've got several options. I've got add a new part number, remove an existing part number, show part numbers, or check part numbers. I'm going to show the stored part numbers, see if I've got any of those software in there. It's going to take it a second. And the reason we're doing this is this hard drive only holds a small amount of, has a limited amount of disk space. So if we upload a new nav database every 28 days or so, and they do add up. Here we go. Let's see. Well, there's room for 206 part numbers, 425 more megabytes. This one right here, DL7-1310-001, that is an old part number. Okay, so we're going to go back to the hard drive main menu. And we are going to remove an existing part number from the hard drive. And there it is, DL7-1310-001. I selected it. I'm going to hit continue. And it's telling me that that part number will be removed from the hard drive. Are you sure you want to remove this part number? And I'm going to select remove.
Nice.
And it tells me it's going to take about a minute. And when it's done, we'll have more hard drive disk space. And when it did it, there's a new configuration index for the hard drive. And that's it.
There you go.
I wish the Polish will do that.
The
The other day I had to do a GPM software upload.
Mhm.
And I went to the plane. And when I clicked on the GPM R7, 216.
of course. That's what I'm saying. You wish they deleted it, is what you're saying.
Yeah.
Like I didn't understand. So you want them to yeah.
Yeah.
That's right.
Like I said, I wish they would do that.
All right. So these are just showing you the different types of tests you can do for the MAT, display unit system test, the brightness test, graphical pattern, CCDs. So the CCU or the cursor, we're going to test that, the disk, or the avionics local area network. Right? MAT display unit, LRU replacement test. What are the differences? Again, the only thing is that you have an LMAT instead of a PMAT. Right? So a laptop maintenance access terminal is the same thing, just much smaller. You're done?
All right.
All right, so 8 o'clock. Let's eat. We come back. We do 12 slides and we go home.
All right, sounds good. You good, yo?
What's the next class today? What is next class?
I think ACMS.
Next is ACMS.
LGMS.
ACMS.
That's what he was asking.
Trying to eat. It was pretty cool.
What?
777.
Honestly, my favorite plane now is the 350, but that plane is it's good enough. You know what I mean?
Mhm.
Like it's like think of it like you can have the luxury car, you can have the 787, and you can have the 350 that touch screen and all that stuff. It's all nice, but this is good enough.
Right.
You know what I mean?
Right.
Like it's enough where they can tell you. And the thing is that I speak to a lot of people and they say it's like the greatest plane in terms of maintenance because when they actually designed it, they like took maintenance input and they asked the airlines like, what is it do you see that you need and stuff like that. So a lot of the stuff is easy for us.
Mhm.
This is the first time that they created something where we can interact with the plane.
Yeah, because of 757, 767,
you need
737.
Tick boxes, you need
You gotta
gas,
go
you gotta go
downstairs, bite the box.
bite the box, exactly, you need a tip. So all those things are, you know what I mean? This is the greatest thing. Is it nice? I mean, is it nice to have a 787 350? Absolutely, but I still think it's not too overwhelming. It's not a lot of things to remember. If there's a problem, go to the map. That's it.
Right.
That's it.
I like it. It's fine with me.
James, what's your favorite plane? 747.
Old level.
747 is good. Good plane. You have Dash 800?
Yeah. But there is sometimes make stress.
It is, right?
Yeah.
I know. Oh, come here for this. My brain is already shocked.
Have you done your lunch already?
I was hungry.
1 minute? Take 1 minute just.
Yeah.
It's not military.
Hey, I eat fast actually.
How's the streaming going?
Stream's going better. I think we move the camera to a lower level. If you have it straight, what happens is the light projector, the light from the projector comes back, reflects back in, so it's a bright spot. If you do it from there and tilt it sort of up, it's much better.
You can see the videos?
Yeah.
Okay, good.
So now Virgilio says he sees them. So
Wow.
that USB,
I don't know who made this.
that's a Pat invention.
Yeah.
Everything's here, including the videos. If you want to overnight it to Virgilio.
Okay. But you can see the videos now.
You could, but then that's also the. I guess you're right, right? You can see the videos now. No need. You're absolutely right. You're absolutely right. And then I can always the files are not that big, so that I can email him
Files.
for like the training manual if he wants to read along. Good point. I get to keep my USB now.
Yeah. I don't have to run to the post office.
Good. You're right.
wife's training.
All right, we ready?
Got a question for you.
What's up?
OPAS.
Yes.
What chapter will that be located in?
31.
31?
See, that's the problem. So it's either 31 and 23.
23.
23 and 31, depending on which one. Depending on what about OPAS you need.
Okay.
That makes sense?
Right.
So if you're talking about like the airing part of it, it's 31. If you're talking about maybe the physical components, it might be 23.
Yeah, I saw 23.
23 and 31.
Because I
23 and 31.
because I
If you go to the chapters, it's separate. So go to 23.
23, 70, 60, something.
So right there, 23 and 31.
it's a airing.
So the airing part of it, yeah. So depending on where it is, depending on what part of it exactly you want to talk, it's airing. That's why I didn't like when I was teaching it.
Mhm.
This CMCS and all those things, I don't really put an ATA because it's fuzzy. It's fuzzy. Like
right,
Ames,
right.
like I showed you, Ames. Yes, it's 31, but it really could be 45. It could also be 31 and other systems like that.
All right,
All right.
no problem. Thank you.
Nope, no worries. Thought you were gonna give me a technical question. That was
No.
easy.
My brain already shut down.
Look, then we only have 10 slides left. Airplane performance, analyzes trends, reports significant events, and troubleshoot faults. Right. What is our ACMS? Again, not only is it the ACMF function that lives on what CPM? Where's the ACMF? It's in this one. Which one is that?
Depends on the airplane.
Okay, Ames 1.
ACMF,
CPM, ACMF, what cabinet?
left,
Very good. If it's on the Ames 2 plane,
standard,
standard.
both
Right.
cabinets.
Nice. There you go. Okay. Just gotta reset the link. Just saying that the link's
The
down.
link went down.